Hi everyone, welcome to day 14 of SQL Fundamentals. Today we are going to talk about index and statistics. So before I start, I just wanted to give a quick disclaimer. This is going to be more of like theory and talking. There will be less of practical which we need to do because when we talk about index statistics, this is more of like we need to visualize and understand what is happening behind the scene rather than like going and creating index indexes and all. Okay, so let me first give an introduction. What is index and how that is connected to statistics? So, index, as definition mentioned, right? You can read that yellow colored. An index is index in a SQL database object that improves the speed of the data retrieval operation on a table. It's like a index in a book. So when you are going to search something in a book, if you have an index, you go through that headings and identify which page is it. You are going to directly pick that page, so that like you don't need to really go from first page to last page to identify where this content is, right? So this is the same thing an index is doing. So index create a page that's index page. So data stores in pages. Okay, I'll talk about that in a different session because that makes things more complicated. So imagine that like there is a place where index related informations are stored. So there um, it will store where each data is located. So when somebody is going to filter a data, it goes go to index and identify where this data is stored, and based on that it directly go and picks that data. That is how index ensure the like query retrieval faster. Clear? So keep this in mind. If there is no index on a table, those kind of tables are called heap. This is a technical term. So when you are writing a query in heap, right, like select star from um, table where id equal to 1, it may be stored in any manner, right? You don't know how it is stored. So you need to read all the places where data is stored to identify like where my data is. Like you are, even if you wanted to search one, you need to go from 1 to 100, make sure that there is no other one because it is not sorted in order. There might be one on the first, one on the last, right? So index help you to arrange the data efficiently and get you the retrieve the data faster. Keep this in mind. Index is arranging the data, so that like it is one common example which I tell everyone whom I discuss is like you are arranging your dress in your wardrobe, right? So when you have to keep it very arranged, and like formally is in one place, other all type of dresses, if you wanted to keep it right, you have an effort initially while keeping the dress, correct? So that's a like when you are going to insert data into database, or like if there is an index on a table, if you're going to insert data into that table, you're going to take some time because you need to arrange it at the right place. But the benefit is where when you are going to take the data back, right? When you are going to take your formal dress, you know where it is, you can go and pick it. You don't need to search entire wardrobe to find a dress, correct? And next thing, suppose you imagine that you wanted to like take all the data, right? You wanted to take all the cloth from your wardrobe out. You really wanted to search it? No, right? So that is the same case here as well. If you are going to retrieve everything, if when you are going to select star from all table, or if you are not filtering the data, index is not going to help. So you have to create an index when you have a requirement to filter the data. When you are going to take everything, you don't really care is it in order or unorder, because you are not specifically going to pick anything. You need everything, right? So that is the same case. Keep this in mind. Index work when you wanted to filter a data. Okay. So we have there are many types of indexes. On a very fundamental, we have clustered index. Yesterday I was in our primary key, foreign key, and other constraints topic. I was talking about indexes. That is why today I took index as a topic. I feel like you should understand what it is. So clustered index is a physical arrangement of your data. When you create a clustered index on a table, that's going to physically arrange your data. So that said, you can create only one, right? You can only physically arrange your data one way. So that is, so you can create only one clustered index on a table. So what is non-clustered index? Non-clustered index is like there will be an additional set of data that would be stored inside database. It's kind of a copy, and that refers to your main data storage location. So that is non-clustered index. And column store index is a way of storing the data compressed in the column manner. So usually data stores as rows behind the scene as well. So now in case of column store, it stores the data in each column together. Okay, so column store does generally help you to retrieve the data when you are going to filter and retrieve the same columns and things like that. We don't need to go into the deep of use cases. The primary goal of this video is to make you understand what is index and what is statistics, how both of them work together, right? So I have just covered like what is index. I have a diagram that help you to understand how data is stored and how you are going to retrieve a data. So here I have an image that having a data from think that it's employee ID. I have the employee from 1 to 1200. Okay, so that is your entire data set. It is from 1 to 1200. So this how it is stored in I have, like, binary tree, right? A binary tree will have two hands kind of mode. This is called balanced tree, not binary tree. So SQL uses balanced tree in indexes. So here in index from 1 to 1200, from the main, it divided that into three. The first index row is storing the data from 1 to 400. Second one is 400 to 800. Third one is like 800 to 1200. And in the next layer, 1 to 1200 is in first data row, right? So here I have to filter the data 1120. So I know it is between 800 to 1200. So it comes to the right page, and from there it will tell me where is okay, 1000 to 1200. I have another data page, and in data row that is already sorted, so you know where you have to like pick the right 1120 as an output. Okay, so you don't need to scan through from 1 to 1200 to identify this value. So you have had like only 1, 2, 3 reads in very high level to get the data. Otherwise you have to read all 1100 or 1200 records to get the data. Okay, I'm not going in deep. We have an index pages, database, all these things, but we are not covering. Just keep understand this. This is the fundamental. And if you are going to read everything, you don't need index. Index works when you wanted to filter the data. Clear? So we'll move on to the statistics. So what is statistics? Because you already have index that help you to retrieve the data faster, and if you don't want index, like you scan the entire data. So where the statistics plays a role, right? And you also might often heard that okay, is your query is performing slow, even you have an index, you need to update the statistics. So what is statistics, right? So as the definition says, it is an estimated row distribution. Okay, so how SQL works? So you have like 10 index created on a table. How SQL knows which index should I pick, and do I really need to pick index? So all these decisions are made based on statistics. And if SQL is going to index, understanding the data and coming back and saying that, okay, index 1 looks good, index 2 looks good, so let me go and pick it. This is going to take a time taking process. So statistics is a summary. So as the second line say, right, this helps to optimize, determine the best execution plan. Execution plan is nothing but a plan which is created by SQL before your query execute. So it define a plan, how this query is going to execute when you click on execute button. Sorry, when you click on execute button only this works, but before the actual execution happen, SQL create an execution plan behind the scene that is the path it goes. So how this define the execution based on the summary of data. So it has to tell, okay, from 1 to 10 this is the data it is, like based on this index this is how the data is summarized, right? There are maybe very high level, do you need to seek the data. So the example which I have seen, right, this is seek, index seek, but if you are going to read the entire data, that is called scan. So based on the statistics, SQL is going to, like a database engine is going to take the decision, should I scan or seek the data. So if you have to go through all the pages, your filter condition is picking most of this data here, right? I don't like going through each nodes and getting the result is little tricky, and this is more time taking than reading the entire data and filtering. Okay, so those decisions are made based on statistics, and statistics will have a summary of that. Okay, from 1 to 100 I have like 2000 records, and 200 to 300 I have like 500 records. So based on that, SQL would be able to take an optimized decision on your like which index should be taken, which way I have to use index, should I really need to take an index. So what is happening in scenarios is, like if you don't have a proper statistics updated, your like database engine is getting fooled by a wrong statistics. So it is going to often take a wrong path. Maybe it is taking index seek where it should have been taken scan based on the actual data, right? You might see some cases, you might still see index seek, that is often called as a better performance method, but that is taking time because based on the latest data status it should have been a scan, right? So that is why statistics is key in performance improvement. So the latest updated statistics will help you to will help the database engine to understand how the demography of the data, which I can which index I can pick, the way how I have to sort, which join, like there are different types of joins, hash and all these things. So which I can pick. All the decisions are being made on stat. However, like index is priority and statistics is even priority if there are like frequent update delete are happening. When you create the index first time, statistics will be created, and statistics also will have all the information. So when you do the frequent delete insert operations, statistics may need to be updated in some cases. Some cases it will be auto updated based on how much percentage of the data is being changed at a time. Okay, so with that we can move to the SQL query window. Most of you might be waiting for the query window which is here. So normal SQL syntaxes, right? So here I am not going to teach you syntax. You all know how to build a syntax in common. So here I have the create statement, and what type of index I need a clustered index, and I'm naming the index on what, on EMB table. I'm going to create an index, and here I am telling what order my index should be created. It's not necessarily to be one column. You can keep writing the column by putting comma here. Index can be created on one column or multiple column. So the data would be stored in the order what you have mentioned in the bracket. Okay. Here I'm going to generate an error. I'm going to create a clustered index IDX clustered on EMB table, and I'm executing. I'm getting an error, right? I expected an error here. So cannot create more than one clustered index on a table DBO EMB. So in our last class we created a primary key column on the employee table. So we have already a index which is created in this table. That is why you are not able to create this primary key created an index, and you can see so many non-clustered indexes are also there. So you can still create a non-clustered index. I have the same code which I have instead of clustered. I changed to non-clustered index name, maybe yeah, IDX clustered. You can change to IDX non-clustered. The best practice is giving the column name as well, or something which help somebody to understand how you can name it, right? You can identify it later. So I have a non-clustered index. I am going to create employee name. So if you are not mentioning descending, it is by default going to consider as ascending. This is created. So now if you refresh here, you can see that non-clustered index is created, right? So you have some options, disabling rebuild. Rebuild will recreate the entire index with the latest data. Okay, so understand that there are even more different types of index. There are called filtered index. Now these indexes are applied on the entire data. Filter index is generally applied on a group of data. Maybe you have like 10 years of data, but you know that you always write query only on the first 2 3 years. So you can create a filtered index only on this 3 year of data, so that you are not wasting the storage by creating index for the entire data. Your query will still perform well because you are always querying only the first 3 year of data. That is clustered filtered index. And we have covered index. um, to talk about covered index, that cover all the column using an include function, so that in non-clustered index itself you will be able to retrieve the entire data. In general case, clustered index, non-clustered index create a data in this way, and it create a key to the main table to retrieve rest of the column. Other than employee name, we have employee ID, age, and all these column. This, if you have to return in your select query, first it will identify uh, the key element or key which it's called lookup. So it goes to the main data table and retrieve the rest of the column. In order to avoid that state, we have something called covered index. Don't get confused with all the terms. Understand that what is clustered index, what is non-clustered index. That is all you have to understand now, and what is the importance of statistics. So I have a dbcc command. This is database command. Show statistics for the employees table. This is my like index, pk employee id. You can see some of the information, and statistics are automatically created now. Yeah, if you go here, right, it created a stat for everything, even idx non-clustered name index, which I have created a few minutes ago. Also I have a stat, and if you wanted to see what is stored in the stat, you can give that dbo emp, and this is my index name. Let's do it live, right? Yeah. So this is giving you some kind of information. What is about index name, number of rows? It has 4 rows. So and steps required for all these little more in detail information. What type of index? It's a string index, yes, because it's name. And density, yeah, density. These terms, right, we will take that in a different session, because there are cardinality, density, and even pages, index pages. All these things is an advanced session which we may need to talk about how the indexes work internally. We talked about how a query execute. It comes to statistics, understand how the data is distributed, and it goes to the indexes and identify the right index, and that would apply to your data. So it is the flow. But even to understand these data points, right, okay, what is density, what percentage of density should I consider, index scan, seek, and what is the range of values, how this range matters, right? All these informations are being uh, tracked or captured and analyzed by the system behind the scene to identify the most shortest path to get your data faster. Okay, those things can be discussed in a detailed advanced session later. So here I just want you to understand statistics is also as important as index when you have a lot of DML, DML operations happened on your data. So hope this video help you to understand what is index, how indexes is working, and what is statistics, how statistics is important in query writing. So I'll write a very basic SQL query with an execution plan so that like you can visualize how execution plan work, and we will conclude the video. Select star from dbo.emp. So I'm retrieving the entire data from the database. Okay, so you don't know like what index is taken or anything, right? So there is a couple of buttons here. One is called estimated execution plan. Without running the query, you can understand like what it is like what index it's going to take. Yeah, so it is going to do a clustered index scan. I'll talk about that. So this is include actual execution plan. When you enable this and run the query, while running the query, what index SQL is taken is what it shows. And live query statistics, its latest feature came in SQL 2016. So this when you have a bigger query, it keep updating the like execution plan status while the query is being run. So I'll show this the execution which is already here. Execution plan came in. So it is saying that we did a clustered index scan to retrieve your data, right? You have a clustered index. What was your clustered index? Your clustered index was on the primary key, correct? PK employee 1. So clustered index will have all the columns, and I'm mentioning like I need all the data. And here most of the cases this is going to be scan. One reason is it's a very small data, so we may not be able to distinguish the data. In some cases we might think, okay, I have a scan, why SQL is taking I am filtering the data, I'm still have a, it should have been a seek, but with a small data you may not be able to distinguish, but still we can try what it results, right? Here I only gave employee name in the column name, and I'm retrieving all data. You can see there is a change. Yes, it is still a scan, but it is scanned on the non-clustered index, because you have a non-clustered index on an employee name, right? So you have a non-clustered index on an employee name. That is why SQL takes the scan on the non-clustered index instead of your clustered index, right? Because the difference is this: clustered index has all the column, all the 4 columns, or 4 or 5 columns, whatever you have. But in non-clustered index had only one column, that is the name. So you only need name to be displayed here. So which is best memory optimized way to retrieve the data is like to pick only the index which is having only that column. So now I am going to write a where condition employee name equal to A. I ran the query. So let us see what execution plan did. And execution plan went and did an index seek on non-clustered index. I'm not keeping the mouse because that's showing a lot of information. Read from the right. It did an index seek, so it identified where A is, and I said about a key lookup in a few minutes ago. So key lookup helped us to get rest of the data, because in my non-clustered index I have only employee name, but I have mentioned star, right? Because I need all the column age and all the information I wanted to result. So in order to show all this column, it has to do a key lookup. So if you wanted to avoid this key lookup, right, you can use covering index. But here I'm not going to create a covering index. I'm just displaying only the employee name here. Then you are going to, because employee name you already have it in the non-clustered, so you don't need to go to the clustered index to read the rest of the information. If I run the query, it will still index seek, but it's going to skip the key lookup step. You can see it right now. It's only non-clustered index which is directly retrieving the data. You don't need a key lookup because you are not reading you don't need to read age and employee ID in this case. Hope this was clear, and it is index seek because you are only filtering a data, but it would have been a scan if you are retrieving most of the bigger percentage of the data. Okay, you have to keep that in mind. It is not the entire data. If you are trying to retrieve like 80% of your data, you are still going to be scan, because that is more optimal method than seek. Okay, hope however it was a little longer video, this help you to understand the fundamentals of querying, like indexes, statistics and everything. If you like this video, feel free to add your comments. If you have any questions, if you wanted to know like how this is working, and if you still have questions, feel free to add it in the comments. Thank you for watching. Have a good day.